Welcome back, everyone. After mastering methods in our first lecture and arrays in the second, today we open one of the most important chapters of your programming journey, classes in C#. Classes are the very foundation of object-oriented programming. They let us design real-world objects in software, organizing both data and behavior cleanly. So get ready, because understanding classes will change the way you think about programming forever. Today's lecture is titled, Classes in C#. Classes are the blueprints, the DNA, from which real objects in your programs are created. Think of them as the master plans. Once you define a class, you can create as many copies or instances of it as you need. You'll see how C# lets you design classes, protect their data, and control their behavior through methods and properties. Mastering classes means mastering real-world software design. Here's the roadmap for today. First, we'll talk about what a class is and how it relates to objects. Then, we'll move on to instance variables, which store object-specific data, and instance methods, which define object behaviors. Next, we'll explore properties, a safer way to access object data, auto-implemented properties for quick setup, the use of the keyword this, and finally, we'll introduce constructors, the special methods that create objects properly. Each topic builds on the previous one, so stay sharp. What exactly is a class? In simple words, a class is a template or blueprint. An object is a real thing created from that blueprint. Imagine you have a blueprint for a car. That blueprint isn't a car itself, but from it you can build many real cars. Similarly, in programming, you can have a dog class, and from it, create a Luna object and a Rocky object, two real dogs with their own characteristics. Important fact, even simple data types like double and int32 in C# are actually full classes behind the scenes, with built-in methods like toString. This shows how deeply classes are integrated into everything in C#. Objects are at the heart of object-oriented programming. Each object bundles together data, called attributes or fields, and behavior, called methods. Key features of objects: abstraction, only show necessary details, hiding complexity. Attributes, like a dog's name, color, or age. Behaviors, actions like barking, eating, running. So when we create an object in C#, we're creating something that looks and acts like a real-world entity, smart, self-contained, and manageable. Classes come in different types. First, application programs, classes that have a main method and serve as the entry point. Or instantiable classes, classes designed only to model things. They don't need a main. They're just blueprints. Remember, every object must be created from a class, and once created, it behaves according to that class's design. For example, the dog class defines what all dogs share, but each actual dog you create, Luna or Rocky, has its own state and behavior. Inside a class, we define instance variables. These store information unique to each object. For example, each dog's age or color. Instance methods. These are the things every object can do, like bark or sleep. And finally, a client program is just another program that uses these classes. It creates objects, manipulates them, and calls their methods. The separation between data and behavior is the key principle here. Each object remembers its own data and knows how to act. Data inside a class should not be directly accessible from outside the class. Why? Because we want to protect it from unexpected modifications. This is called encapsulation. To achieve this, we use the private keyword when declaring fields. Private fields are visible only inside the class itself, not to any external code. This protection ensures that your objects stay consistent and valid throughout their life cycle. In C#, a class starts with the class keyword, followed by a legal name. Example, class car. You can also add access modifiers like public, accessible everywhere; private, accessible only inside the containing class; protected, accessible inside its class and derived classes; internal, accessible within the same project. Choosing the right access level is critical for designing secure and maintainable code bases. There's a huge difference between local variables, exist temporarily, only inside methods. Instance variables, belong to the object, exist as long as the object exists. Local variables are short-lived. They disappear once the method finishes. Instance variables, on the other hand, persist throughout the object's life and represent its state, like a person's name, birth date, or ID number. To define data fields inside a class, we use field declarations like private int ID number. This means each object will have its own independent ID number field. We can also define instance methods to operate on these fields, like printing, changing, or calculating values based on them. This separation between fields and methods is what allows objects to be both data carriers and action performers. Remember, just declaring a class does not create an object. Object creation is a two-step process. First, declare a reference, employee myAssistant. Second, instantiate the object using new myAssistant equal new employee, or combine them in one line, employee myAssistant equal new employee. When you use new, C# calls a special method called a constructor, which sets up the new object properly. Objects are first-class citizens. You can pass them to methods just like numbers or strings. Here, we have an employee class with a method called welcome message. We create an object and pass it to another method, which then triggers its welcome message. This modularity is what allows object-oriented programs to scale up, from small apps to massive software systems. Here's a working program example. Two employee objects are created, a worker and another worker. They are passed to a helper method display employee data. Each employee's welcome message is printed separately. Notice, each object keeps its own independent state, even though they use the same class design. That's the real magic of classes and objects, reusability and individuality combined. Directly exposing instance variables to the outside world is risky. That's why we create properties. Properties act as a safe, controlled bridge between the object's private fields and the outside world. Through properties, we can validate, restrict, or format access without compromising the object's integrity. Properties are an elegant solution that combines the best of security and usability. Now let's dive into properties, one of the most important parts of class design in C#. Suppose you have a private field, like private string name. How can other parts of the program safely read or modify name? Instead of giving direct access to the field, which is dangerous, you create a property. The getter reads the value safely. The setter modifies the value safely. Think of a property like a controlled gate. It lets users in and out, but you stay in control of what happens. Properties protect your data while still making your classes flexible and usable. Now let's focus on the first piece of a property, the getter. The getter is an accessor method whose job is to retrieve the value stored in a private field. Notice, it's a method that simply returns the value of the private field. The naming convention is to start with get, followed by the name of the field. Key idea, getters give read-only access to private data without letting external code modify it directly. This is a crucial part of encapsulation, controlling access to the object's internal state.